Let's do a little more homework help. This is, I think, chapter 3.1, question D, thinking about the way we measure prediction errors in statistics and machine learning. So it starts out, what x value minimizes the sum of the absolute distances from the values 1, 3, and 8? So as you might guess, I've got this set up in Desmos. So here I've got the values 1, 3, and 8, and I can slide those if I need to later. And if I had to kind of come up with one number that was as close as possible to the values 1, 3, and 8, what does it mean to be as close as possible? So in part 1 here, we're saying minimize the sum of absolute distances. So we could say x minus a, absolute value of that, absolute value of x minus a, plus absolute value of x minus b, plus absolute value of x minus c. Hopefully you agree that each of those is the absolute distance between x and a or x and b, and this is the sum of those absolute distances. And here's the curve we get. Not much of a curve, is it? Kind of interesting. Let's see it. So it seems to have a sharp bend here, a sharp bend there, and a sharp bend there. It looks like well, it's just Desmos is just giving us the intersection with the y-axis there. So what x value minimizes that? It seems to be here at x equals 3. And then another part of the question says, repeat but for the sum of squared distances rather than absolute distances. So we could say x minus a squared plus x minus b squared plus x minus c squared. You might remember that in linear regression or trendline stuff, you can do the sum of the squared distances of the points from the line. So it takes a little bit of zooming, but there's our function that's the sum of the squared distances. So for any value x, in fact we could, we'll call this s of x. So I could say, like, what's the sum of the squared distances at x equals 0? And that's pretty large, because if I have x at 0, this is 1 unit away, this is 3 units away, this is 8 units away, square 1, 3, and 8, add them up, you get 74. It gets a little better at if I choose 1, so that's 0 from here, it's 2 from there, and it's 7 from there. 2 gives me 38, 3 gives me 29, 4 gives me 26, 5 gives me 29 again. There's no reason this has to be integers. You can use 4.1 or 3.99, but it seems like the minimum is here at x equals 4. And you could use calculus to take the derivative of this. It's not so hard. You just do power rule and really easy chain rule and a little bit of simplification and find where the minimum is. It turns out it's at 4. And the minimum of the sum of absolute distances is at 3. And then we ask, how do our answers, the 3 for part 1 and the 4 for part 2, how do those relate to the mean and the median of 1, 3, and 8? Well, the median is the middle value of 1, 3, and 8, and that was the thing that optimized the sum of absolute distances. So if you're looking for a single value that's as close as possible to other values, in the sense of summing their absolute distances from that one point, then the median is your answer. And the mean of 1, 3, and 8, if you just do 1 plus 3 plus 8 divided by 3, is 4, and that happened to be the value that minimized the sum of the squared distances. And then the question is that a coincidence? Well, in the next parts of the problem, we add one more value, 1, 3, 7, and 8, and we can repeat this, so we could have, I'll add d equals 7, and we can throw one over here, x minus d squared, and I'll take the absolute value of x minus d. And I have markers for my points here, so I'll just add another one, d comma 0, there we go. So now, which value minimizes the sum of the squared distances for my 4 points? It seems to be 4.75. Is that still the mean? Well, let's add that in here. I really should have done a plus b plus c. That was 4, and then plus d seems like it doesn't match, but because this was 4.75, not 6.33, but now I have 4 points, so I should divide by 4. And indeed, it's the point that minimizes that sum of square distances is the mean. So this is worth thinking about. People often ask, why am I doing like squared distances? Why is an absolute distance better? And there's nothing wrong with absolute distance. It's just that there's a lot to say. There's a lot of good stuff about the mean, and it turns out the mean is what naturally minimizes the sum of squared distances. So maybe it shouldn't feel quite so strange to use squared distances because we were kind of already implicitly doing that when we use the mean. How about for the sum of absolute distances? What's the median of 1, 3, where did D go? There it is, 1, 3, 7, and 8. The median, since there are 4 data values, or an even number, we'd say go halfway between the 3 and the 7, which is 5. And does 5 minimize the sum of absolute distances? Well, yes, 5 does, but so does 4 point something, 5 point something, 6 point something. So while we say the median is 5, really any number between the two middle data points minimizes that sum of absolute distances. It's just that the median is kind of a nice happy medium, you might say. All right, so that's how we can think about the mean and the median in terms of how good they are at being close to the data points, and how this relates to measuring other errors, like in trend lines, the distance of the points from the line. We often use squared residuals there, squared distances, which means that that trend line is in some sense acting like a mean of the data in 2 dimensions.